Hi students, we are studying in this video about IPv addressing, IPv4 addressing. So, a host typically has only a single link to the network. It may be maximum of two. If one is wired, another is Wi-Fi, we can have two different link from a host. The boundary between the host and the physical link is called an interface. So we use the term interface which represents the boundary between the host and the physical link. That is, every host is connected to the internet with a link, and this link, this physical connection is known as an interface. Similar to that, the boundary between the router and any one of its link is also called an interface. Here it was the physical connection between the link and the host was named as interface. Then in the next bullet we heard the boundary between the router and its link. This is also interface. So everything connecting to the physical network, whether it may be a router or a host, then this link or this boundary is known as an interface. Then actually we say that IP address is for a host for unique identification, but actually it is for every interface. That is, IP address is associated with each interface. And each IP address is 32-bit long, and therefore we can have a total of 2 raised to 32 possible IP addresses. These addresses are typically written in dotted decimal notation. In this figure we can see 223.1.1.3. It is a sample IP address. It is in decimal numbers and it is in the dotted notation. There are 4 segments and each segment can have of 8 bits, and 8 into 4 is equal to 32 is the total number of bits, and we can have a total of 2 raised to 32 possible IP addresses, and this is equivalent to about 4 billion possible IP addresses. Then each IP address is associated with an interface. That is what the thing we studied from the previous slide. And it is represented in the decimal notation. Though it is represented in the decimal notation, its actual value is in terms of binary, and it is represented in the decimal fashion. And here we can see an island. It is a group of computers connected to a single interface of a single router. There are multiple interfaces for a router. In this figure we can see this router is having 3 different interfaces, and these 3 different interfaces are forming 3 different separate independent networks. And in a single network there can be multiple interfaces or multiple hosts connected. And there is an important peculiarity. For each of the hosts connected to a single island or single subnet. This is known as subnet. The initial part 223.1.1 up to this first 3 segments in the same island or in the same subnet, first 3 segments are common and the last segment is different. That makes the uniqueness in between the host in a single subnet. So for each device, for each host, there will be an Ethernet switch connected, and the switch is actually connected to the router. This is what the actual configuration. A subnet is formed with the help of a switch, and the switch is connected to the interface of a particular router. And each interface on every host and the router in the global internet must have an IP address that is globally unique. a portion of an IP address will be determined by the subnet to which it is connected. So from this IP address, we get the subnet address as well. As I explained in the previous slide, first three segments in the common subnet in a single subnet will be common, and this determines the subnet to which a host is connected. Similar to that, in this Wi-Fi router, there is 223.1.3, 223.1.3. Up to this first three segments, everything is common. So it makes a single subnet. Then subnet addressing have two different parts. One is the higher order bits. First three segments in this case are higher order, and last segment is in the lower order bits. So we can identify how a subnet is if the common part of the higher order bits together forms the name of a subnet, and it is physically reachable. All the devices in a common subnet will be physically reachable without intervening a router. That is, from this subnet, suppose I want a datagram to send to another subnet, then only through this router I can communicate. But if it is in a single subnet, then without intervening a router, other hosts can be connected physically. So in this figure, we can see there are three subnets for a single router. Then, to determine the subnets, detach each interface from its host or the router, creating islands of isolated networks. I think it's clear for you. Each isolated network is called a subnet. If I remove the link, this physical link from this router, then it will form a single island. So this is belong to a single interface. So we can represent the upper part and lower part with the help of a subnet mask. This subnet mask 24 means 8 into 3, 24. That is, first three segments of each 8 bits total makes a 24 bits. So the first 24 bits are representing the subnet address, and the remaining 8 bits are used for representing the host identifier. So this kind of IP addressing is known as CIDR, or classless interdomain routing. CIDR, this is what the type of IP addressing currently we are following in the internet terminology. So what is CIDR, or classless interdomain routing? CIDR is also known as classless addressing. So in IP addressing, there are classful IP addressing as well as classless IP addressing. Then classless IP addressing is known as CIDR. In classful IP addressing, the number of hosts within a network always remains the same depending on the class of the network. This we will study in detail in the coming slide. But here it is CIDR. In CIDR, we identify a subnet and a host, or subnet portion and host part, by representing with a slash followed by the number of digits. This X represents the number of bits in the subnet portion, or a number of bits used for representing the subnet. In this example, we can see 4 different segments. Though it is 4 different, the subnet mask is 23. That means higher order 23 bits are used for representing the subnet part, and the remaining 9 bits are used for representing the host part. So in this figure, it is clear that one more bit is taken from the last but one segment for representing the host part, and the remaining total 23 bits in the higher order are taken to represent the subnet part. That is why it is represented in this pattern A dot B dot C dot D dot D slash X, where X is the number of bits representing the subnet portion, and the remaining bits are used for representing the host part. So the host part must be unique for each host. This makes the unique IP addressing for each host in a subnet. And the subnet part will be common for all the host devices in a single subnet. Next, we study about the classful IP addressing. This is actually the obsolete technology, but still we need to study how this classful IP addressing represents the unique identification for each host. The IP address is an address having information about how to reach a specific host. Actually, the use of IP address is to reach a specific host in a especially outside the LAN. Inside the LAN itself, that is important. Inside the LAN, there must be unique addressing, but for IP addressing having importance when it comes in the global scenario or the outside LAN. The IP address is a 32-bit unique IP address and is having an IP address space of 2 raised to 32. That is a common thing for CIDR as well as for this classful IP addressing. Generally, IP address is written in the decimal notation and the value of any segment is between 0 and 255, both included. This 255 is the total 8 bits are represented by 1111, the maximum digit, biggest integer value that can be represented by 8 bits 1 is known as 255. That is the difference. That is the range of IP address. Sorry, a single segment in a dotted notation. So, what is classful IP addressing? In this figure, we can see an IP address is divided into two parts. Higher order part is network ID and lower order part is host ID. This convention is similar to the subnet ID and host ID in the classless IP addressing or CIDR. Here use the term network ID instead of subnet ID. Both are same actually. But we have only 5 different types of subclasses for an IP addressing: Class A, Class B, Class C, Class D and Class E. Class D and Class E are used for special purposes, so it is not under our consideration of IP addressing. Just remember this name multicast address, and it is Class E is for the reserved purposes. Then in case of Class A, we have 2 raised to 14 number of hosts, that is 8, 8, 8, 8 into 3, 24 number of hosts can be connected in a network of Class A type, whereas in Class B type network we can have 2 raised to 16 number of hosts. In Class C we can have 2 raised to 8 number of hosts. So here the number of hosts is 2 raised to 8, means we can have 2 raised to 8 different hosts or different devices with a unique identification can be represented. Suppose we want to connect a host in between this Class B type and Class C type, that is in between 2 raised to 8 and 2 raised to 16. Suppose I want 2 raised to 9 or 2 raised to 10 number of machines. It is impossible for a network to connect such kind of varying number of devices. If I take 2 raised to 8 and it will be very less for an organization, suppose, then they have to automatically switch to Class B type of network. That will be a huge number, that is 65,634. That is a numeric value according to 2 raised to 16. So it will be a huge number, but 2 raised to 8 will be a less number for them. So in such kind of situations, we will be utilizing this much 2 raised to 16 number of hosts, but most of the IP addresses will be wasted or unused, and we are forced to take the 2 raised to 16 number of host devices. This is what the drawback of the classful IP addresses. So this can be eliminated in CIDR, where we can represent the number of bits that can be used for representing the subnet part. So it can take a varying number of host devices in the power of 2 can be represented. That is what the advantage of CIDR over classful IP addressing. So CIDR is the current IP addressing system which we are in living with. This much only regarding the IP addressing. Thank you.